Hello friends, today we prove why square root of 2, square root of 3, in general square root of p where p is any prime number are irrational numbers. And we prove this by contradiction. So first we prove why root 2 is actually irrational number and then we will go to root p. So first we prove root 2 is an irrational number. Root 2 is an irrational number. And we prove this by contradiction. So let's prove this by contradiction. Let's prove this by contradiction. So suppose square root of 2 is a rational number. Suppose square root of 2 is a rational number. Square root of 2 is a rational number. Therefore, square root of 2 is equal to a by b. Where what are the conditions on a and b? A and b both are integers. This is not enough. Integers, moreover, b is non-zero, and important condition GCD of a and b is equal to 1. This is important. GCD of a b is 1. Okay. Now root 2 is equal to a divided by b. Therefore, 2 is equal to a square by b square, squaring both sides. Okay. So square of root 2 is 2 and square of a by b is a square by b square. Therefore, a square is equal to 2 into b square. So a square is multiple of 2. Therefore, 2 divides a square. First, this is equation number 1. 2 divide a square. 2 divide a square means 2 divides a into a. 2 divides a into b. A means 2 divides a or 2 divides a. Now why? Now recall, if p is prime, recall this theorem, p is prime and p divides a into b, then p divides a or p divides b. That is, if p is any prime number and that divides product of two integer, then p guaranteed divide one of the integer. So here 2 divides a into a, therefore 2 divides a or 2 divides a implies 2 divides a. Number 2. 2 divides a, therefore a is multiple of 2, that is a is equal to 2 into m, where m is some integer, m belongs to z. Now use this value in equation number 1. Use this value of a in 1. Now what is 1? See, equation number 1 is a square is equal to 2 into b square. Now a is equal to 2m. So this becomes 2m square is equal to 2 into b square. So this is 4m square is equal to 2 into b square. So this is 2 into m square is equal to b square. This shows that b square is multiple of 2. B square is equal to 2 into some integer. M square is integer because m is integer. B square is equal to 2 into some integer. Therefore, 2 divides b square. Now note that 2 is prime number. 2 divides b square. Again, 2 divides b into b. And 2 divides b into b implies 2 divides b or 2 divides b. Same reason. Which reason? P is prime number and p divides a into b, then p divides a or p divides b. Okay. Now 2 divides b, this implies this 2 divides b. number 3. Now from 2 and 3. From 2 and 3. So in 2 we have 2 divides A, and in 3 we have 2 divides B. So from 2 and 3, 2 divides A and 2 divides B. Therefore 2 is divisor of both A and B. 2 is divisor of both A and B. Therefore 2 is common divisor of A and B. And 2 is common divisor of A and B. Therefore GCD, greatest common divisor of A and B, it is guaranteed greater than or equal to 2. This is contradiction. This is contradiction. Because GCD of A and B is equal to 1. See, here GCD of A and B is equal to 1, and after some work what we get, GCD of A and B is greater equal to 1 and greater equal to. So therefore root 2 is irrational number. Root 2 is irrational number. Now next we prove root p, where p is any prime number, is also irrational number. Now we prove root p in bracket p is prime. We prove root p is an irrational number. Again proof by contradiction. Suppose root p is not irrational, that is root p is a rational number. So suppose root p is a rational number. Therefore root p is equal to, again say, a by b, where a, b integers, b is not equal to 0, and GCD of a and b is equal to 1. Again this is important for remaining proof. GCD of a, b is 1. Now root p is equal to a by b, therefore p is equal to a square by b square. So a square is equal to p into b square, and this implies, a square is equal to p into b square. This implies p divides a square. P divided a square implies p divides a into a. This implies p divides a. Note that this is number 4. Okay, p divides a. This is number 5. Now p divides a, therefore a is equal to p into some n, where n is integer. Now use this value in 4. Therefore 4 is a square is equal to p into b square. So this is p into n, its square is equal to p into b square. So p square n square is equal to p into b square. Now p into n square is equal to b square. So b square is multiple of p. Therefore p divides b square. P divides b square. So p divides b into b. This implies p divides b. Number, I think it is 6. Okay. Yeah. So from 5 and 6, 5 and 6, we have P divides A and, not or, and P divides A and P divides B. That is, P is divisor of both A and B. Therefore, now P is prime. P is greater than or equal to 1, and it is divisor of both and A and B. So P is common divisor of A and B. So GCD of A and B is greater than or equal to P. And this is contradiction. This is contradiction to GCD of A and B is equal to 1. And therefore root P is irrational number. So if P is any prime number, then root P is guaranteed irrational number. So in general, root 2, root 3 continue up to root P are all are irrational number. Thank you.